Hello and welcome to Info for Triple E. This is the fourth lecture of Control System video series for GATE and UGC-NET. I am Akshay Juneja and the topic of today's video lecture is transfer function, that is open and closed loop. So starting with this video, first we have to understand that what is a control system, right? So a control system is a combination of elements arranged in a planned manner where each element causes an effect to produce a desired output, which means that we have various input elements and we rearrange them or combine them so that we get a desired output. The input is a reference input and the output is called a controlled output, right? So here is a pictorial representation of the generalized control system. We have RT, then control system, then CT. So coming to the classification of control system, what we have is we have open loop control system and closed loop control system. Basically, if we have a feedback, then it is a closed loop control system, else it is an open loop. So a closed loop can be of positive feedback or a negative feedback. Now what is a transfer function? It is calculated for linear time invariant system and it is given as the ratio of Laplace of output to the Laplace of input, that is CS divided by RS. And always remember that initial conditions must be 0. So also try to find transfer function for impulse input to avoid additional poles and or zeros. Okay, we have to avoid the additional poles and zeros. Therefore, if nothing is given in your question, then consider your input as impulse input. Now what are poles and zeros? If we write transfer function in generalized form, then it is given as k into s minus z1 into s minus z2 so on s minus zn and divide by s minus p1 into s minus p2 so on s minus pm. Now this can also be represented as k into 1 plus t1s plus 1 plus into 1 plus t2s and so on into 1 plus tns. Similarly, in denominator, we can write up to m terms. Now these notations are given as k is the gain factor, z is zeros, p is poles, t in denominator are time constants. Always remember in denominator only. In numerator we do not care. Now if this n is greater than m, it implies that RTF is improper. And obviously if number of zeros are greater than number of poles, so there must be a pole which will lie at the infinite, right? Which will lie at infinity and its order will be n minus m. If n is equal to m, then TF is proper, right? And if it is less than m, then TF is strictly proper, and it will be reverse the case of n greater than m. That is 0 of order m minus n is at infinity. Now the properties of transfer function are represented. Always remember that transfer function is represented in the s plane, right? This is the s plane. Okay, s is equal to sigma plus j omega. So where sigma is the real part and s is equal to j omega is the imaginary part, right? So TF is never in time domain. For minimum phase system, poles or zeros, they are absent there. And for non-minimum phase system, they lie in the RHS of S plane, right? Now, what is open loop control system? Only accurate if calibration is good, it is easy to construct, and stability is high for linear system. Also, the performance degrades for non-linear system. So here is the pictorial representation of the open loop control system. Now coming to the closed loop control system, accuracy is high because of feedback. It is obviously it is complex because of more components, and it may or may not be stable. But the performance is better for non-linear systems. Here is the pictorial representation of the closed loop control system. Now moving on. the analysis of transfer function. Remember that this is the most important part of this PPT, right, or this lecture. Now the characteristic equation is given as denominator of closed loop transfer function equal to 0, right? The denominator part of your TF, when it is equated to 0, then we get the characteristic equation. Now what is this characteristic equation? We will learn about it in detail in upcoming lectures. Now the method of analysis is, remember that in this picture OLTF is the open loop transfer function, right? CLTF is the closed loop transfer function. Now always remember, to appear in competitive exams like GATE and NET, you require two things, right? You require speed and you require accuracy. And I'm pretty sure that if you will follow any material, you will get the accuracy, right? But there are some tips and tricks. If you with which you will follow, then you will get the speed as well, which will help you secure more marks than other students in less amount of time. So if OLTF is given to you as numerator divided by denominator, right, then it's equivalent closed loop transfer function. Sorry, not equivalent, but for that OLTF, this CLTF is given as numerator divided by denominator plus numerator. And if you have CLTF as numerator divided by denominator, then your OLTF will be given as numerator divided by denominator minus numerator, right? For OLTF to CLTF, we add both numerator and denominator, and for CLTF to OLTF, we subtract them. Okay. So to find the DC gain for OLTF, this is very important point. To find DC gain for OLTF, use limit s tend to 0 into limit s tend to 0 for OLTF. So thank you so much. I hope that you liked the video. If you like this video, then click on the thumbs up icon down there, and also please share it with your friends so that they can also learn something new, right? Thank you so